Bismillah ar-Rahman ar-Rahim. Dear students, our lesson today is about an introduction in complex numbers. An introduction in complex numbers. Learn the imaginary number. What is the imaginary numbers? The imaginary numbers I, denoted by I, it is defined as the number whose square equals negative 1. Negative 1. Then I squared equals negative 1. I equals square root of negative 1. I equals square root of negative 1. Then I square equals negative 1, and the negative square root of negative n equals square root negative 1 times n. Square root by distribute square root, then square root of negative 1 times square root n. Square root of negative 1 equals I, and square root of n. Square root of n. That is the imaginary numbers. Where n belong to R. Where n belong to R. And the numbers in the form 2a, 2i, negative 5i, square root I are called the imaginary numbers. Any number contain I, this number is imaginary number. So we write negative square root of negative 3 as square root 3i, because square root negative 3 equals square root of negative 1 times 3 by distribute square root, then square root of 3 times square root of negative 1. Square root of negative 1, as we said, equals I, then equals square root 3i, and so on. Critical thinking, تفكير عميق أو تفكير أعلى شوية. If A and B are two negative real numbers, A and B are two negative real, question here is, it is possible that square root of A times square root of B equals square root A times B? Explain your answer by giving a numerical example. Let A equals negative 2 and B equals negative 3. Then square root of A multiply square root of B, square root A multiply square root of B equals square root of negative 2 times square root of negative 3. As the definition, square root of negative 2 equals square root 2i multiply square root of negative 3 equals square root 3i by multiplying equal square root 6 I square. I multiply I equals I square. I squares equal negative 1. Then the result equals negative square root 6. Negative square root 6. That is the relation number 1. Number 2, the right side square root of A product B equals square root of negative 2 times negative 3. Negative 2 times negative 3 under the square root. Then the result equals square root 6. This is the right side, number 2. We notice that left side equal negative square root 6. Right side equals square root 6. Then the two sides are not equal. Then the relation square root A times square root B equal square root A times B, not at all. Integer power of I. The number I satisfies the laws if of identical, which we studied before. It is possible to express the different powers of the number I as the following: I power 1 equals I power 4 equals I power 2 times I power 2 equal negative 1 times negative 1 equals 1. I squared equal negative 1, I cube equals I squared times I equal negative I, and so on. In general, I power 4n means n here mean even number or even power, because 4n equals I power 4n plus 1 is 1 is equals 1, but for I power 4n plus 1 equals I power 4n plus 2 equals negative 1, and so on. Then find each of the following in its simplest form. I power 30. We can solve I power 30 as the following. I power 30. First, we can take I power 2. I squared, because I squared equal negative 1. 30 divided 2 equals 15. I power 2, as we mentioned, equals negative 1. Negative 1 power 15. The power here is odd. The odd converted negative into negative as it is. The power, if the power is odd, the negative is still negative as it is. Then the result equals negative 1. Then I power 30 equals negative 1. Number B, I power 40, I power 43. As we mentioned, I squared divided 43 divided 2 equals 21, and remainder I, because 21 times 2 equals 42. Then the power here is 43. Remainder I. Negative, or I power I squared equal negative 1. Negative 1 power 21 times I. The power here is odd. Then negative 1 becomes negative 1. Negative 1 power any odd number equal negative 1 times I. Then the result equals negative I. Number C, I power negative 61, converted negative into positive by turn I power negative 61 from numerator into denominator. I power 61, and solve as the following. I power 61 equals I squared power 61, not 16, 61. That is 61 divided 2 equals, the remainder is 30, because 30 times 2 equals 60, and the remainder I, that is 30. I squared equal negative 1. Negative 1 power even equals whole 1 times I equals I. Then the number becomes 1 over I. Then we multiply by I squared. I squared equal negative 1. Then negative I squared over I. Then we can cancel I with I. Then the result equals negative I. I with I, the result equals negative I. Number D, I power 4n plus 19. We can separate this number into I power 4n multiply I power 19. I power 4n equals I squared power 2n times I power 19 equals I squared power 9 times 2 equals 18 from 19, and remainder I. This number I squared equal negative 1 power 2n. 2n here is even. Then the number becomes whole 1, positive 1 multiply I squared equal negative 1. Power odd, 9 is odd, equal negative 1. And remainder I, multiply the three numbers, then the result equal negative I. That is the result, negative I. Try to solve each of the following equations. Solve each of the following equations. The first equation, 3x squared plus 27 equals 0. By adding the additive inverse, 27 equal negative 27, divided 3, then x squared equals negative 9. By taking square root, then x equals positive or negative. Square root negative 9. We solve this equation in complex. If we solve this equation in z or q or n, the solution set is phi, because there is no real number. Square root negative 9 it not belong to real number. This is in complex number, but in real or q or z or n. By taking square root, then the square root of negative 9, as we mentioned, negative 1 times 9, negative 1 equals square root 9 times square root 9 I times I. Then the result equals x equals 2 numbers. F is 3 square root 9 equals 3i, or x equals negative 3i. Then the solution set in complex number equals 3i or negative 3i. Number B, 5x squared plus 245 equals 0. Then 5x squared equals negative 245 divided by 5, then x squared equals negative 49. By taking square root, then x equals positive or negative. Square root of negative 49. We mentioned before, square root 49 times square root negative 1, then x equals positive or negative 7i. Then solution set equals 7i and negative 7i. 7i and negative 7i, as we mentioned before. Number C, like number A and B, 4x squared equals 75 minus 100. The additive inverse of 100 is negative 100. Then the result equals negative 25 divided 4, then x squared equals negative 25 over 4. By taking square root, then x equals positive or negative square root of negative 25 over 4. Then x equals positive or negative square root of 25 is 5, square root of 4 is 2, and negative square root of negative 1 is I. Then the solution set equals positive 5 over 2i and negative 5 over 2i. Positive 5 over 2i and negative 5 over 2i. Negative 5 over 2i. Positive and negative. Equality of two complex numbers. The two complex numbers are equal if and only if. If and only if. The two real parts are equal. The two real parts are equal. And the two imaginary parts are equal. Then if the two real equal and the two imaginary not equal, then the two numbers not equal. The two conditions must be satisfied one with the other, not one and one. If A plus BI equals C plus DI, then the whole or the real part A equals the real part C, and the imaginary part B equals the imaginary part D, and vice versa. For example, find the value of x and y which satisfies the equation 2x minus y plus x minus 2y I equals the real part here. The real part here is 2x minus y equal the real part in the right side is 5. The imaginary part in the left side equals x minus 2y, and the imaginary part here is 1 I equals 1 I equals 1. To solve these two equations by the ways we mentioned before, multiply the second equation by 2, then the first equation as it is 2x minus y equals 5, and the second equation 2x minus 4y equals 2 by subtracting one of the other, negative, positive, negative, then 3y equals 3 by dividing 3, then y equals 1 by substitution in first equation or second or third or fourth, then 2x the first equation by substitution in the first equation, 2x minus 1 instead of y is 1 equals 5, then 2x equals 6 divided 2, then the value of x equals 3. The value of x equals 3. Then the value of x and y, x equals 3 and y equals 1. Try to solve. Find the values of x and y which satisfy each of the following equations. The first number A, 2x plus 1 plus 4yi equals 5 minus 12i. As the same, the real equals the real part. The real part is 2x plus 1 equals the real part is 5. By solving this equation, then 2x equals 4, then x equals 2. That's the value of x. The imaginary part here is 4y equals the imaginary part here is negative 12 divided 4, then y equals negative 3. That is the value of x and y in number A. Number B, the real part is 2x minus 3 equals the real part is 7, then 2x equals 10 by dividing 2, then x equals 5. That's the value of x. The imaginary part is 3y plus 1. The imaginary part in the right side equals 10. Then 3y equals 10 minus 1, 9 divided 3, then y equals 3. That's the value of y. Operations on complex numbers. It is possible to use the commutative, associative, and distributive property to add or multiply complex numbers as shown in the following examples. Let's see this example. Find the simplest form, the result of each of the following. Number A, 7 minus 4i plus 2 plus I. We add in this question 7 minus 4i plus 2 plus I. When we add two complex number, add real with real, and imaginary with imaginary. Real 7 and real 2 equals 9, real part. Imaginary part, negative 4i plus I equals negative 3i. That is the result. Number B, multiply 2 plus 3i with 3 minus 4i. As we mentioned in the first 2 multiply by 3 and 2 multiply by 4. Then after that 3i multiply by 3 and 3i multiply by 4, negative 4i. 2 multiply 3 equals 6. 2 multiply negative 4i equals 8i, equals 8i. Then 3i multiply 3 equals 9, positive 9i. Negative 3i multiply 4i equals 12i squared, 12i squared. Then 12i squared, i squared equal negative 1. Negative 1 times 12 equals positive 1. This number becomes positive 12. Positive 12. Negative 1 times negative 1 times negative 12 equal positive 12. 12 without I. That is a real part. The real part. 12 plus 6 equals 18. That's the real part. The imaginary part, negative 8 plus 9 equals I. Positive I. That's the result, 18 plus I. Try to solve. Find in the simplest form the result of each of the following. Number A. 12 minus 5i. 12 minus 5i. Between bracket. Minus bracket, another bracket, 7 minus 9i. First, we must distribute negative on the second expression. Then the result equal 12 minus 5i minus 7 positive 9i. Then we add real with real. Real 12 minus 7 equals 5. Imaginary with imaginary. Negative 5 plus 9 equals positive 4i. Positive 4i. Number B. 4 minus 3i. 4 minus 3i. Multiply 4 plus 3i. 4 plus 3i. That is the two expression in the form of the difference between two squares. Difference between two squares. We must multiply first, and second multiply second. First multiply first equal 16. Second multiply second equal negative 9i squared. 9i squared. First multiply first and second multiply second only. Then the result 16 I squared equal negative 1 times negative 9 equals positive 9. The result equals 25. 25. If we multiply two imaginary numbers in the form difference between two squares, or we mentioned in the form conjugate numbers, then the result equals real numbers, equals real number. Number C. 5 minus 6i. 5 minus 6i multiply 3 plus 2i. 3 plus 2i. Then in this example we must distribute 5 on the second expression and multiply negative 6i with the second expression. 5 times 3 equals 15. 5 times 2 equals 10i. Negative 6i times 3 equals negative 18i. And negative 6 times 2i equals negative 12i times I equals I squared. Then we mentioned I squared equal negative 1. Negative 1 times negative 12 equal 12, positive 12. Here positive 12. 12 plus 15 equals 27. That is the real part. The imaginary part 10 negative 18 equal negative 8i. That is the result, negative 27 negative 8i. After that, the conjugate numbers. What's the meaning of the conjugate numbers? The two numbers a and bi and a minus pi are called the conjugate numbers. The conjugate numbers in the form difference between factorization difference between two squares. For example, 4 minus 3i and 4 plus 3i are two conjugate numbers. Find the simplest form. find in the simplest form the value of each of the following. Number A 4 minus 6i over 2i. If we have imaginary number in the denominator, we must multiply by the conjugate of this denominator. Conjugate here 2i, the conjugate is negative 2i because this number is positive 2i. The conjugate is negative or different sign of the imaginary part. The different sign of the imaginary part. This imaginary part, the sign is positive. The conjugate, the sign is negative. The sign is negative. Then we must multiply numerator with numerator and denominator with denominator. The numerator equals negative 8i and positive 12 12i squared. The denominator equal negative 4i squared. Then the numerator becomes negative 8i, negative 12i squared equal negative 1 over the denominator equals 4i squared equal negative 1 times negative 4 equal positive 1. Divided 4 or simplify, the result becomes negative 2i, negative 2i, negative 2i, negative 3, negative 2i, negative 3 as you see. Number B 3 minus I over 2 minus I. We must multiply the conjugate of the denominator equals 2 plus I over 2 plus I. Then the numerator, if we multiply numerator, the numerator equals 3 times 2 equals 6, 3 times I equals 3i, negative I times 2 equal negative 2i, negative I times positive I equal negative I squared. The denominator in the form difference between two squares, first multiply first equals 4, negative second multiply second equals I squared. Then the numerator becomes 6 plus 1 equals 7, 3i negative 3i equals 3i negative 2i equals 1i, and the denominator equals 5 because 4 plus 1. That is the answer of this question. We can write in the form 7 over 5 plus 1 over 5i. We can write the number in this form or in this form. That's right and that is right. Critical thinking. Find in the simplest form. A 1 minus I power 10. We can distribute 10 into I power I minus 1 minus I power 2 all power 5 because 5 times 2 equals 10. Then we can find the result of 1 minus I power 2 1 minus I power 2 all or 1 minus I times 1 minus I, that's power 2, and find the result. 1 times 1 equals 1 times I negative I times 1 negative I, negative 1 negative I times negative I equals positive I squared. Then the result equals this I squared equal negative 1 positive 1 equals 0. Then the result becomes negative 2i. Then this expression equals negative 2i all power 5. Then negative 2 power 5 and or multiply negative I power 5 also. Distribute the power I power 5. Negative 2 power 5 equals negative 32. Negative 32. And I power 5, as we mentioned, equals I squared power 2. This is R, I power 4 times I. Times I. I power I squared power 2 equals positive 1. Positive 1 multiply negative 32, then 32 I. That is the result of this question. The last example in our lesson, discover the error. Discover the error. Find the simplest form of, this is a question. Find the simplest form of 2 plus 3i, 2 plus 3i, all power 2 multiply 3 minus 2 minus 3i, 2 minus 3i. Ahmed's answer, Ahmed answer the question like here, and Kareem answer the question like here. Ahmed find the result. The result of Ahmed is 26 plus 39i. The final result of Kareem is negative 10 positive 5i. To discover the error, we must solve the question by ourselves. To discover who is right, Ahmed or Kareem. Then we can distribute the expression 2 plus 3i power 2 into 2 plus 3i times 2 plus 3i multiply 2 minus 3i. Then we take the last two expression in the form of conjugate numbers. Then the result is the first expression as it is, 2 plus 3i. The second expression, the result is first multiply first equals 4. Negative second multiply second equals 9i squared. Then 2 plus 3i as it is, 2 plus 3i multiply 4 plus 9, because I squared equal negative 1 becomes 9. 4 plus 9 equals 13. We can find this expression. 13 times 2 equals 26 plus 13 times 3 equals 39i. That is the right answer. The students who write as we write or answer as we answered, this is the right answer. The first equals 26 plus 39i as we answered the question. The second equal negative 10 plus 15i. Then can we discover Kareem wrong or Kareem answered wrong in any step? Let's see. Kareem said 2 plus 3i power 2 times 2 minus 3i. Then he answered, he finds the result of 2 plus 3i all power 2 as 4 positive 9i squared. This is the wrong answer. Because if we answered 2 plus 3i all power 2, we said first square equals 4, second square equals 9i squared, and first times second times 2 equals 2 times 2 4 plus 3 times 3 equals 12i. Then the result equals 4 minus 9 equal negative 5 plus 12i. Then he answered 4 plus 9i squared. This answer is wrong. The wrong answer is Kareem. Kareem answered, or answered, the answers of Kareem is wrong. That is the end of our lesson. Thank you.